Hey, hi and welcome back. Now let's start with this video, which is about Introduction to PCB Layer Stackup. So what is layer stackup? So let's try to understand that now. A layer stackup refers to arrangement of copper layers and insulating layers that make up a PCB prior to board layout design. So basically a layer stackup actually consists of a copper layers. Okay, there will be multiple copper layers in the layer stackup, and along with that there will be multiple insulating layers, okay, in the layer stackup. And we consider this layer stackup, or we need to think about this layer stackup before we start with the layout design of our hardware. So always remember, whenever you start with the layout design, first of all you have to think about the layer stackup. Okay, now in our case, as we are dealing with the 2-layer PCB, so in case of 2-layer PCB, this layer stackup is actually not that complicated. But when you go for a higher layers, for example 4 layers or 6 layer or 8 layers or 12 layers, in that case the complexity of the layer stackup actually increases. Okay, so let's try to understand this layer stackup in more detail, and also let me show you how exactly the layer stackup of a 2-layer PCB look like. So this is basically the layer stackup for the 2-layer PCB, and depending on the number of layers, this layer stackup will actually change. Okay, so you can consider a layer stackup like a like a sandwich. Okay, and in case of sandwich, there are actually multiple layers. Like on the bottom layer there will be bread, then there will be mustard will be there, then there will be tomato, then there will be a layer for cheese, then there will be a layer for spinach, and on top of that again there will be a layer of bread. Okay, in the same way, in case of PCB, there are actually multiple layers. So you can see here, as we are dealing with the 2-layer PCB, so there will be actually only 2 copper layers. Okay, so one copper layer will be on the top, and then the second copper layer will be on the bottom, and these 2 copper layers will be actually isolated by a core. Okay, and we also call this as a dielectric. And most of the time, this particular core, in case of 2-layer PCB, it's going to be FR4. Okay, so it's basically the name of material, which is FR4, which stands for flame retardant 4. So this is basically the name of material which is actually most widely used, when we deal with the 2-layer PCB. Okay, and again there will be different material for the core, but FR4 material is actually one of the most popular material when we deal with the 2-layer PCB. And again you can see on top of copper layer there will be a green masking. Okay, and along with that, on top of this green masking there will be silk screen. In the same way, on the bottom side also, as the PCB is always going to be the symmetric, so on the bottom layer there will be green masking, and again on the bottom layer there will be silk screen. Okay, so that's how basically a 2-layer stackup look like. Okay, and again you can see here I have actually given the thickness of each layer. So for top copper layer, you can see I have given a thickness of 35 micron, which also means 35 micrometer. Okay, so that's basically 35 micron, which is basically the thickness of top layer. And again in case of bottom layer, if you see, the thickness of bottom layer is basically 35 micron, which is 35 micrometer. And then the core thickness, it's basically it's not 1.5 micron, it's basically 1.5 millimeter. Okay, so it's basically 1.5 millimeter, and this total thickness starting from this point till this point, it's actually 1.57 millimeter. Okay, and if we include the thickness of this green masking and this silk screen, then the total thickness from this point till this point, it's going to be 1.6 millimeter. Okay, so most of the manufacturers that you will see, or from where you will order the PCB with 2 layers, this is actually going to be the default stackup, in which the top copper layer, it's going to be of thickness 35 micron, then the core thickness, it's going to be 1.5 millimeter, and bottom layer thickness, which is bottom copper layer, its thickness is going to be 35 micron. But again, depending on the application, we can actually go for the different thickness of copper layers. Okay, so the copper layers are actually available in different thicknesses like 17.5 micron, then 35 micron is there, then 70 micron is there, then 90 micron is there. So likewise, the 2-layer PCBs will be available in different thicknesses, okay? And based on the application with which you are dealing, you are actually going to use, the respective thickness or a specific thickness for the top and bottom copper layer. And if I have to tell you, most of the time, this 35 micrometer thickness is actually very popular, and mostly people use the thickness, copper thickness of this 35 micrometer. You can also go for a 17.5 micrometer thickness. It's completely fine. And when we deal with, power electronics project, or when we are dealing with the high current application, in that case, we actually go for the higher thicknesses like 70 micron and 90 micron. Okay. So I hope that this point is clear to you. So based on the application, we can change the thickness of top copper layer and also the thickness of bottom copper layer. Okay. But always the thickness for top copper layer and bottom copper layer, it's going to be the same. Okay. If you choose a 17.5 micrometer thickness for the top copper layer, then it's going to be the same for the bottom copper layer. As I told, the PCB is always going to be the symmetric. So the layers which are there in the PCB, they will be symmetric and they will be of same thickness. Okay. And again, depending on the application, we can actually go for the different thicknesses of the core. Okay. But 1.5 micrometer thickness, it's going to be default, and it will be provided by the most of the manufacturers. Okay. And in case you are dealing with an application where you need a different or a specific core thickness, in that case, you have to consult the PCB manufacturer, and you have to ask them what are the different core thickness available. Okay. And based on that, you have to actually input that information in the CAD software that you are using. So at this moment, you just remember that this is basically the layer stack up that we are going to use. And most of the time, people are actually going to use this particular layer stack up when they are going to deal with the 2-layer PCB. Okay. Now let me show you this stack up in comparison to the PCB that we are going to design. So this is basically the PCB that we are going to design in this particular topic. And let's try to understand the different layers which are actually present on this PCB with the help of the layer stack up that we discussed just now. Okay. So the first layer is cell screen layer. So whatever you see on this PCB in white color, that entire part is actually cell screen. Okay. So this white color circle is cell screen. So all the things that you see, all the markings that you see in white color, these all markings are actually called as cell screen layer. Okay. And which is actually on top of green masking layer. And then this entire part or this entire green color that you see, it's actually called as green masking. The reason it is called as green masking, it's because the reason is obvious. It's because the color is green. That's why it is called as green masking. If you choose a masking color as black, then it will be a black masking. If you choose a color as a violet or purple, then it's going to be a purple masking or violet masking. Okay. So everything that you see on this PCB in green color, it's basically a green masking. Then below the green masking, there is actually a copper layer, which is not visible here. So then there will be below the green masking, there will be top copper layer. Now on this PCB, wherever you see the silver color, it's basically a tin coating. So initially there was copper layer, and then this particular PCB is actually coated with tin, and that's how we got this tin coating on this particular PCB. Okay. So we are done with the cell screen, then we are done with the green mask layer, then we are done with the top copper layer. Then the next layer is core, or we also call it as dielectric. So you can see here in this part, there is actually no copper. Okay. So this is actually a dielectric of material FR4. Okay. And again, if you see here, there is actually no copper here. So this entire, it's actually the exposed dielectric. Okay. So that's how dielectric look like. And it's going to have a thickness of 1.5 millimeter, which we already discussed. Okay. So it's going to be 1.5 millimeter. Then again on the bottom layer, there will be bottom copper. Okay. So again on the bottom layer, there will be bottom copper. Then above the copper layer, there will be green masking layer. And then above the green masking, there will be cell screen. So that's all about the PCB layer stack up. I hope that now you have a good clarity about the PCB layer stack up. And if someone asks you what is layer stack up and what exactly it consists of, I hope that you will be able to answer the question confidently. Alright, so that's what I wanted to tell in this video. I hope that every single thing that we discussed is now clear to you. Now I will see you in the next video, which is about introduction to DXF file. So I will see you in the next video now.